Hello guys, how you doing? I'm Rahul and you are watching the Concept Builder. And today guys, we're gonna discuss a very simple topic and very important for understanding of your distillation topic. And that topic is called as the TXY diagram. Okay, so this is how it looks like. So I'll show you. It is a typical how a TXY diagram looks like, and you may have seen it and you might get confused like how does it work, what does it explain, and how it's important. So it's very important for distillation, and if you are new to mass transfer and new to distillation, this topic is very fundamental. So let's start with basics. So let's see what we are doing. Basically there are some assumptions that I'm gonna make. So the assumptions are that first thing is it's an binary mixture. Okay, so this TXY diagram that we are going to draw is for binary mixture. Okay, second thing that something I'm going to make is that what is A and B. So basically you have two components, as I told that it is a two component mixture. So one is A and another is B, and I'm assuming that here A is our more volatile component. Okay, MVC is more volatile component. What does it mean? That its vapor pressure is higher than the another one. So if you don't know about the vapor pressure, then there is a video on the channel, you can see. So A is more volatile component. Okay, so what does it this say? That when this liquid mixture of A and B, when it is at a particular temperature T, when it will be equilibrium with its vapor, which is this is your vapor phase, its mole fraction of the more volatile component mole fraction will be Y, and at the same time the liquid mole fraction will be X. Okay, so this is X and this is Y. So you may have understood what is X and Y. Okay, so both are the mole fraction of more volatile component only. Okay, so for example, let's say you have a mixture. Let's say you have a mixture of 60% ethanol plus 40% water. Okay, so here ethanol is your A component, basically your more volatile component. So if X is here is 0.6, and assume that at temperature of let's say 35 degree, if I maintain this mixture, its vapor that will be produced at equilibrium, the composition will be Y, but how much it will be, that is called that we can find with the help of TXY diagram. So that's the basic idea, that it's at equilibrium only. Okay, now let's understand what are the different phases in this diagram. So on the y-axis you can see it's a temperature. So as I told you that it is a temperature of mixture. So at which temperature you are maintaining this mixture. Okay, and you have to keep it constant so that the equilibrium can achieve and you can get Y and X. Okay, simple. Now this region below this red line is basically a liquid region where your mixture is only liquid. So at temperature, let's say for example, let's assume that I have a solution of XA mole fraction. Okay, so this mixture, I took a mixture whose mole fraction was XA. Okay, XA mole fraction. Here A is more volatile component. Okay, so here is XA. So let's say, let's take this point over here, let's call it G. At G point the temperature is TG. Okay, from y-axis, and its mole fraction we already taken at XA. So what is the state of this mixture? As you can see, it is below this line. That means it is liquid. So there is no vapor at the TG temperature. There is no vapor at being produced. This liquid is basically subcooled. It is not started boiling yet. Okay, so this is the thing. Now what will happen if you keep heat? So you increase the temperature. Okay, so you move along this axis, you increase the temperature. So as you increase the temperature, the mole fraction will remain same, because you are only heating the liquid only. So there is no addition or removal of any component, but you keep heat, and until you reach this point, which has been marked by red. You can see this point is where you hit this line, and this line is called as bubble point curve. Why it is called bubble point? Reason is very simple, that at this point the first vapor bubble will form, or the liquid will just start boiling. So here what will happen when the temperature will reach, let's call this point A point. So at this point the temperature will be T, of course. So at this temperature there will be first bubble of the vapor will form, or you can say that vapor will just start to form. So the vapor will just start to form when the temperature will be TA, and that vapor that will be formed, its composition YA. You can tell. How you can tell? Because this vapor will be also at this same temperature. Okay, and as this temperature is same, if you extend this line, so same temperature, you have to extend this line here, and this composition is your YA, and this is the composition of the vapor that is being produced. Is it clear? Now let me tell you again. It is very, very important, guys. At this point, your liquid whose composition was XA, how you know? You have to go like this, vertically like this. It is just start boiling because it is on this line, and the vapor that will just be produced, the small amount of vapor that will be produced, will have composition of YA. And why I am saying that a small amount of vapor again and again? Because it is a binary mixture. Okay, here is another concept will come. So let's understand this. So I hope you have understood this. So this vapor that will be produced will have composition of YA, and that composition maybe you can track down here. So it may be around, let's say, 80%, like that, whatever will be the value. So this Y is of vapor, this X is of liquid. So this curve is for vapor, this curve is for liquid. Okay, I hope you have understood the basics, what is happening over here. Okay, now what will happen if I again increase the temperature? Okay, so at TA temperature, the first amount of vapor got produced. But what will happen if I maintain the same temperature also? The vapor will produce. Okay, now if I provide more heat, let's say if I heat, or simple terms, if I increase the temperature of mixture, what will happen? This vapor will, more and more vapor will be produced, because it has started boiling, and if I give more temperature, more heat, then it will boil again. But what will happen now? Now, there is a very important concept you should understand this, because it's a binary mixture, or so say more than one component mixture. So if it were pure component, okay, it's very important. Pure component will boil at constant temperature. So once, for example, let's say water at 1 at atmospheric pressure will boil at 100 degrees. So whatever water amount you have, all the water, let's say 1 liter, 1000 liter, 1 lakh ton, whatever, okay, whatever amount of water you have, it will boil at only 100 degree only. So once it's reached 100 degree, it will start boiling, and its temperature will remain 100 degree irrespective of how much heat you supply. Okay, whatever amount of heat you supply, because it's a pure component, its temperature will remain constant. But this will be not in the case of binary mixture. So if you increase it, when you heat a binary mixture, its temperature will increase, it will change. Why? Because this more volatile component will go into this vapor phase, and as it is more volatile, means more amount of this component will go into vapor phase. That means more amount of B, or the heavy component, will accumulate in the liquid. That's why it will change the composition of the liquid, and that's why different composition of liquid will have different temperature of saturation. Let me explain here. So what is happening here? when this just start boiling, it was here. Okay, now if you give more heat to the system, what will happen? More amount of this more volatile component will go into the vapor phase, and because of this, the mole fraction in the liquid will decrease, because the more volatile component has gone to vapor phase. So in liquid, its amount is decreased, so its mole fraction is basically decreasing. So we will move along this line, and as you can see, we will move along this line. Its temperature of the system will increase. So at this composition, it will have this temperature, at this composition, this temperature, like that, and we will move like this. And at every point there will be, you can say that what will be the vapor phase composition. YA2 you can say, YA1 you can say, like that. Okay, so this is very important concept. Let me again tell you, because it's kind of like you may get confused. Okay, so don't be confused. What I'm saying is that you have to understand this graph very clearly, because this graph tell you a lot of things about the system, what is happening, what is not happening, what will happen if you heat the liquid more and more. So these are very fine concepts. You will learn only by practice and experience. Okay, correct. Now let me explain again. So for a mixture of any composition, there is a temperature at which it will boil, and when it will boil, it will produce a vapor of this composition, and it should be at this temperature. So a mixture of X composition at temperature T, TA, let's say XA composition, TA temperature, will have a YA composition of vapor. Okay, this is the basic idea. And when you give more and more heat, is the liquid solution will not boil at constant temperature. That's what I'm saying. If you heat more and more, its temperature will change, because its composition will change, and at each composition there is a different temperature. That's what I'm trying to say. I hope you understand this. If you don't get it, write in comment. I'll try to explain again, but the idea is simple. At different composition, the system will boil at different temperature. Or in another way, if you give heat to the liquid, it will change its composition, because it's a two component mixture. So its composition will change, because one will be vaporized at higher rate than the another one, like that. So its composition will change, and as composition will change, its temperature will also be changed. So the mixture will boil at different temperature. Okay, so that is a basic thing you should remember. So let's again start with the example that suppose you add mixture over here, and where you heat it and you reach at this point, and you get the first vapor at this point, let's say N, let's call it M, like that. And when you heat, when the first vapor is produced, you get this composition. Okay, now what will happen if you give more heat? Again, as I told you, there will be change in the liquid composition, so the system temperature will change, and we will move along this line. But here is an interesting thing. But as we give more heat, as the composition will change, the amount of liquid, the amount, I'm saying the physical, the amount of liquid left in it will also change. Suppose the liquid amount is L, and the vapor produced amount, let's say in kg or more, it is, let's say, V. So that suppose here, now let's say we give more heat, and we have reached at this point where the temperature of the system is, let's say, T T2, okay, and the X composition here will be X2, and here Y will be Y2, okay. Let me again clear it. What does it mean? That I started with here when the temperature was something like this, and after when I gave more heat, what happened that the some amount of more volatile component got into vapor, and at some time the composition of liquid phase become X2 and the vapor phase become Y2. Okay, so at this time we have some X2 composition of liquid and some vapor is there which has composition of Y2, and its temperature, what is its temperature? Is T2. How we will get from the horizontal curve is T2, so its temperature is T2. Okay, so its composition, what is the amount of liquid and what is the amount of vapor, the actual amount. So there is one rule which is called as lever arm rule. So let me tell you here, lever arm rule, which is say that this liquid by vapor amount, okay, so here this liquid by vapor amount is actually proportional to this length of this thing. So for example, let's say this composition here the value of X here is XA, here is Y2, as I already tell you, and here is X2. So the L by V, so you have to remember, so it is the L by V is basically Y2 minus XA, basically length of this line divided by XA minus X2, basically length of this. Okay, so this is the actual liquid and vapor amount. So in some question in exams they may ask you, so again I'm gonna tell you here. So this is your line, here is a mixture where initially you had the mixture, its composition is XA, and when the mixture has vaporized enough, its composition, the amount of liquid and vapor has changed. So let's say it's X2 and this is Y2, the vapor phase, and again this is your this thing. So the L by V is, L is basically this length of this segment, okay, so which is Y2 minus XA divided by the V is XA minus X2. So how you can remember, basically you can remember for the trick, you can say to remember this is the liquid line. So for the for the length of this segment you have to write length of this segment, like it's inverse, like here this length and this is vapor, like that. So you can remember on your way how you want to remember it. You can make your own trick like that. So it was also important thing that lever arm rule is there. What's next? So you have understood the lever arm rule, and as I told you that as you will go move further, there will be things like that. Okay, one thing again I am clear, what are the X and Y are the equilibrium concentration, okay, that you must have get it. Both are the equilibrium concentration. So there is another type of diagram which is used, that is basically made from here from this only, and that is you mostly see in makeup Thiele and all that, but the origin is this one. So for the makeup Thiele famous diagram Y by X, YX, that diagram you have seen, but the origin of that diagram also come from here, and you have to understand this diagram very important to understand you this. So I hope you understand how does it work. I know the video is quite long, but you have to be patient because this is something very important. Now let's talk about some important things, because the first thing is that this diagram, this TXY diagram, is plotted at constant pressure. Okay, it is very important. So another assumption I'll write now over here, that it is at constant pressure. And why it is important? Because this is another, because when you fix the pressure only, then you have then only you can draw the TXY diagram. Otherwise degrees of freedom will be higher and you can't fix the state of the system. If you don't know about the degree of freedom, we'll talk about it in another video. Okay, so you have to remember that it should be plotted at constant pressure, and it is a T. What is T? Is the temperature of your mixture. Okay, what is X or Y? These are the equilibrium mole fraction of your more volatile component. That's it. You have to understand it. Okay, now simply I'll again tell you some other things maybe. So let's quickly draw this diagram again, just for your some other things that maybe what we can consider over here. So the how to draw and how it will look like, that you should remember. So it's look like this eye like structure, eye, the human eye. Okay, so suppose you are here, over here you have a liquid over here, which is that composition of X1, and the vapor you produce at this time has the composition of, let's say, Ya. So this is your vapor. Now if you take out the vapor and make liquid, so okay, so XA composition, your liquid you had, and if you boil at T temperature, let's say TA temperature, then if you want to know how much will be the vapor composition, you can see from here that it's Ya. Okay, if you have a liquid mixture of XA composition, XA, if you boil it at TA temperature, the vapor that will be produced will have Ya composition. Correct. Now you take this Ya vapor and you make again liquid out of it. So you remove the heat, you condense it, and you make liquid. That liquid you will make will have again XA composition. XA dash you can say, because it is XA, because this is the composition of liquid, which will be same as vapor, because you have condensed each and every amount of vapor. So you have just changed the states. So again you got liquid. Now again you make vapor out of it, and you will get another vapor which is a concentration, let's say YB. Now you have got here. So here was Ya, now it is YB. Now tell me, this is YB, this is Ya. You can see that YB is greater than Ya. Basically what you have done, you have enriched the vapor again. So first the liquid composition was XA, you got a vapor of Ya. So first enrichment you got here. So in the vapor phase you got some enrichment, you have increased the concentration of liquid. Basically you are doing distillation. Now again you made liquid out of it, and again you make vapor. So that vapor has again got enriched, and if you repeat this stage, you will keep enriching the vapor again and again. And that's what we do in actually fractional distillation. We have multiple stages, and each stage basically we are doing the same thing. So that's what we are doing. Okay, so it is very important for you to understand. Correct. Now the terms you have to remember, this is called bubble point and this is called dew point. Why it is called dew point? That's clear. That also nothing serious about this. So I told you up to this point that if you keep heat, if you heat this mixture, which we started from here, right? We had a solid liquid mixture, not solid actually. We have complete liquid mixture, and we reach at this point, it produces some vapor which has composition Ya, but when we give more heat, this liquid amount start decreasing and its composition start decreasing, and we got some lines like this. So at different point you will get like, but what will happen if you vaporize all liquid? So at this point, basically what you have done at this temperature, when you get this temperature, this whole amount of liquid will be in vapor. So the L will be 0. As you can see from the L by V rule also, this L is length of basically this Y composition minus X composition. At this point Y and X both are equal, so this L is 0. Basically you don't have any liquid left. So at this time you can see this vapor composition is equal to liquid composition. So at this point Y equal to A, Y equal to X. So whatever liquid you fed, the same composition of vapor you got. basically you didn't get any enrichment. Your distillation, you failed in distillation. So this also tell you another thing, that if you don't have liquid and vapor contact, if it's 100% vapor, there is no distillation. Okay, because there is no enrichment, because y equal to x at this point. We want y greater than x for our distillation, correct? So this is another point. And if you are interested in superheat it, if you again increase this temperature, you will get in this region, and this whole is a vapor region. So you have pure vapor in this region. Okay, the same composition, you will have a vapor which is higher temperature vapor, not a saturated vapor. So again the same thing. And if you come from top also, then also you can reach the same point. Suppose you have vapor over here, you cool down the vapor, you will reach at this point where you will get the first drop of liquid which has this composition. So that's why it's called dew point. So dew is like a drops, right? So this is called dew point line. Why it's called dew point line? Because if you have vapor at here, if you cool down, when you reach this curve, it will produce the first drop of liquid with this composition, the dot line right here. And this is called dew point because it's making dew, or you can say that is making the first drop. Okay, and when you cool it more and more amount of liquid will be formed, and again at this point, when you reach this point, everything will be liquid and x is equal to y. So there is a different thing. So you have to operate in distillation. For distillation to happen, you have to operate in this liquid plus vapor region, because here only y is greater than x. Otherwise here x equal to y, here x equal to y. For the same line, of course, you have understood this. So these are the all things, and I hope you understood this because it's a quite interesting topic. In my initial video, I have already mentioned this topic, but it was short, and I thought that as this topic is very interesting and it requires a lot of understanding, because you can't understand in once. When you think more and more about it, you came to know more and more other things like that. So it was it.